it all goes back to the sarcomere arrangement. Okay? Remember how we talked about when a muscle is just a little stretched, it contracts a little better than if it's too compressed? The heart works like this too. When the heart is a little stretched in end diastolic volume, in other words, when it's a little fuller than it wants to be, it contracts with more strength and more completely. Okay? It's an anatomic relationship. It has to do with how the sarcomeres are arranged in the heart muscle. The more stretched it is, the better and more completely it contracts. As long as we're in the physiologic range, right? No, we can't just add 400 milliliters to the ventricle and have it contract extra super strong, all right? You still have to be in the physiologic range. But as long as you are, it means that as EDV increases, ESV decreases. Yeah, I do math stuff too, right? Okay, so if that's the case, if EDV goes up, or when EDV goes up, if ESV goes down, it means that a change in EDV makes a big change in stroke volume, right? Because stroke volume is EDV minus ESV. So if we make EDV bigger and ESV smaller, we're going to get a huge stroke volume because we're increasing on both sides. So that's the Frank-Starling relationship. It can be cited really easily, which is the more blood that goes into the heart, the more blood comes out. It's just a lot harder to do that with a mechanical pump than the way our pump works because of this relationship, right? So it helps to balance. It makes perfect sense because if the heart gets extra blood, it has to pump out more blood, otherwise you're going to get a backup, right? You're going to start getting into heart failure. So the Frank-Starling relationship is present in all of us. In health, it works great. It can kind of fall apart in disease a bit.